In a world filled with mysteries and unexplained phenomena, the existence of extraterrestrial life has long been a topic of fascination and speculation. Countless theories of alleged sightings have raised questions about the possibility of beings from other worlds visiting our own. However, with the advancement of technology and the study of science, evidence has started to emerge that could potentially confirm the existence of aliens and their visits to Earth. In this groundbreaking documentary, we delve into the scientific evidence that suggests we are not alone in this vast universe, and that aliens have indeed paid us a visit. From ancient civilizations to modern sightings, the idea of aliens has always captured our imagination. But could there really be intelligent life forms out there, similar or perhaps even more advanced than us? This documentary promises to unravel the mystery and bring forth evidence that may change the way we view our place in the universe. Science has always been the key to unlocking the secrets of the universe, and in this case, it may hold the answers to one of the biggest questions of all time. Do aliens exist? Join us on a journey through time and space as we explore the scientific studies, experiments, and observations that suggest the existence of intelligent life beyond our planet. Brace yourselves for an eye-opening experience as we embark on a scientific adventure to uncover the truth about aliens and their potential visits to Earth. Get ready to have your beliefs challenged and your mind blown in this thrilling documentary that proves that science can indeed provide evidence of extraterrestrial life. The concept of aliens and UFOs visiting Earth has been a topic of fascination and speculation for centuries. With advancements in science and technology, the idea of extraterrestrial life has become a popular subject for research and exploration. While many theories and claims exist, the science behind aliens and UFOs remains a mystery. Is there any scientific evidence to support the existence of aliens? With the vastness of our universe and the possibility of other habitable planets, it seems almost inevitable that there must be other forms of intelligent life beyond Earth. However, despite the countless sightings and encounters reported over the years, the existence of aliens remains unproven and shrouded in mystery. So, is there any scientific evidence to support their existence? Let's take a closer look at the evidence and theories that support the possibility of aliens. Belief in extraterrestrial beings can be traced back to ancient civilizations, with depictions of alien-like creatures found in paintings and carvings. These early speculations were often rooted in religious or mythological beliefs, and there was no scientific basis for their existence. It was not until the 16th century, with the advent of modern science, that the concept of aliens began to be explored with a more scientific approach. One of the earliest recorded theories on the existence of aliens was proposed by Italian philosopher Giordano Bruno in the late 16th century. Bruno believed that the Earth was not the center of the universe, and that there were countless other planets like ours, with potentially intelligent life forms inhabiting them. His theories were met with strong opposition from the Catholic Church, and eventually led to his execution for heresy. Another notable example was put forward by German astronomer Johannes Kepler in 1610. He suggested that the moon and planets in our solar system were inhabited by intelligent creatures based on their observable motion and behavior. While these early theories were largely based on speculation, they laid the foundation for future scientific investigations into the possibility of extraterrestrial life. Fast forward to the 20th century, and the scientific community began to take a more rigorous and methodological approach to the search for extraterrestrial life. In 1960, astronomer Frank Drake conducted the first modern scientific experiment in the search for alien intelligence. Known as the Drake equation, the experiment aimed to estimate the number of intelligent civilizations in our galaxy that could potentially communicate with us. The equation took into account factors such as the number of habitable planets, the likelihood of life developing on these planets, and the likelihood of intelligent life capable of communicating. While the results of the equation are highly debatable, it provided a framework for the future scientists to base their research and investigations. In 1961, the University of California, Berkeley established the first Search for Extraterrestrial Intelligence, or SETI program. This program involves using radio telescopes to scan the universe for any potential signals or communication from alien civilizations. Despite decades of research and funding, no concrete evidence of intelligent life has yet been found. The Drake equation and SETI program are just two examples of the many specific efforts being made to search for extraterrestrial life. Other notable initiatives include the Kepler mission, launched in 2009, which has discovered thousands of planets outside our solar system, and the construction of the extremely large telescope in Chile, the world's largest and most powerful telescope, capable of identifying potentially habitable exoplanets. Despite the advances in technology and the numerous scientific initiatives attempting to find evidence of alien existence, we have yet to find any concrete proof. This has led to what is known as the Fermi Paradox, named after physicist Enrico Fermi. The paradox raises the question, if the universe is so vast and there are potentially billions of habitable planets, why have we not encountered any other intelligent life? There are numerous theories attempting to explain this paradox, ranging from the idea that we are the only intelligent civilization in the universe, to the notion that extraterrestrial beings may be avoiding contact with us intentionally. Another popular explanation is that advanced civilizations may have already visited Earth in the past, but evidence of their presence has been lost or destroyed. While the search for intelligent life continues, there is considerable evidence supporting the existence of microbial or simple forms of life elsewhere in the universe. One example is the discovery of microbial fossils in a Martian meteorite in 1996, although this finding remains controversial and debated. Additionally, in 2015, NASA's Mars Reconnaissance Orbiter detected evidence of liquid water on the surface of Mars, indicating that the planet may have all the necessary conditions to support microscopic life. Similar discoveries have been made on Saturn's moon, Enceladus, and Jupiter's moon, Europa. The presence of liquid water and the organic compounds on these moons further suggests the possibility of microbial life. One of the most compelling arguments for the existence of alien life lies in the discovery of life forms in extreme environments on Earth. For example, microbes have been found living in extremely hot temperatures near hydrothermal vents in the ocean, in high salt environments, and even in acidic conditions. These findings suggest that life is adaptable and can thrive in seemingly uninhabitable conditions. With this in mind, it is entirely possible that life may exist in similar extreme environments on other planets or moons. In 2017, the United States government declassified footage of unidentified flying objects recorded by Navy pilots. This footage gained widespread attention and reignited public interest in the possibility of alien life. However, the release of this classified information has sparked renewed debate and research into the existence of UFOs and their potential connection to alien life. It has also led to the establishment of the Unidentified Aerial Phenomena Task Force, a government-funded program aimed at further investigating these sightings. In conclusion, while there is no concrete evidence supporting the existence of aliens, there are numerous theories and observations that make their existence plausible. The vastness and complexity of our universe make it highly improbable that we are alone in the universe. With ongoing scientific advancements and initiatives, we may one day have an answer to the question of whether aliens truly exist. Until then, the search for extraterrestrial life continues, and the possibility of their existence remains a fascinating and intriguing mystery. So how does the Drake equation help in estimating the number of potential alien civilizations in our galaxy? Are we alone in the vastness of the universe, or are there other intelligent beings out there? This question has led scientists and researchers to explore the possibilities of finding life beyond Earth. But how do we even begin to estimate the number of potential alien civilizations in our galaxy? This is where the Drake equation comes in. The equation itself is relatively simple, as it consists of only 7 variables. However, each of these variables represents a complex and ever-changing factor, making it difficult to come up with a definitive answer. Let's dive into the various factors of the Drake equation and how they contribute to estimating the number of potential alien civilizations in our galaxy. The first variable in the equation is R star, which represents the rate of star formation in our galaxy. This factor takes into account the number of stars that are born each year in the Milky Way. Since stars are essential for sustaining life, this is a crucial component of the equation. Moreover, R star also takes into account the type of stars that are formed, as not all stars are suitable for supporting life. For example, red dwarf stars have a longer lifespan but are dimmer, making it difficult for planets around them to be in the habitable zone. The second variable is FP, which refers to the fraction of stars that have planets in orbit around them. With the advancements in technology, we now know that most stars have at least one orbiting planet. In fact, Recent studies have estimated that there could be as many as 40 billion Earth-sized planets in the habitable zones of stars in the Milky Way alone. This means that the chances of finding planets with conditions suitable for life are significantly higher than previously believed. Next in the equation is NE, which stands for the number of planets per star that are capable of supporting life. It is estimated that a third of all planets outside our solar system fall within the Goldilocks zone, where the conditions are just right for liquid water to exist. Water is vital for sustaining life, and so the presence of these planets increases the chances of finding habitable worlds in our galaxy. However, it is important to note that just because a planet is in the habitable zone does not guarantee the existence of life. There are many other factors to consider, such as the planet's atmosphere and composition. The fourth variable is FL, which represents the fraction of planets where life actually develops. This is a crucial factor, as it takes into account the conditions necessary for life to arise. Earth, for example, had the right combination of elements, liquid water, and a stable climate for life to evolve. However, it is still unknown how frequently these conditions occur on other planets. Scientists are constantly searching for the building blocks of life, such as amino acids, on other planets and moons in our solar system to better understand how life can arise in different environments. Fi, the fifth variable, refers to the fraction of planets where intelligent life evolves. This is another critical factor in the equation, as it narrows down the search to civilizations that have evolved to be intelligent. The emergence of intelligence is thought to be a rare occurrence in the universe, as it requires not just the right conditions, but also a series of chance events, such as the extinction of dinosaurs that allowed for mammals to thrive and eventually evolve into sentient beings. The sixth variable is FC, which stands for the fraction of civilizations that develop technology capable of communicating with other worlds. This is where the search for extraterrestrial intelligence comes into play. With the use of radio telescopes and other advanced technologies, scientists are constantly scanning the skies for any signals that could potentially be from other intelligent beings. However, this factor also takes into account the possibility of a civilization choosing not to communicate or being unable to do so due to limitations in their technological abilities. The final variable in the Drake equation is L, which represents the length of time for which a civilization can communicate with others before becoming extinct. This is perhaps the most uncertain factor in the equation, as it is difficult to predict the lifespan of a civilization. However, it is essential to consider this factor in estimating the total number of potential alien civilizations in our galaxy. For example, if a civilization only existed for a brief period before becoming extinct, the chances of us detecting them would be significantly lower compared to a civilization that has been around for a longer time. Now that we have a better understanding of the different variables that make up the Drake equation, let's try to use this formula to estimate the number of potential alien civilizations in our galaxy. According to recent studies, the Milky Way is estimated to have around 250 billion stars, of which 20% are believed to have planets in the habitable zone. using these numbers, we can calculate that there could be around 50 billion potentially habitable planets in our galaxy. However, it's important to remember that these numbers are based on the current understanding of the variables in the Drake equation, which is constantly evolving as we make new discoveries. Another important point to note is that the Drake equation only takes into account potential alien civilizations in our galaxy. There are an estimated 2 trillion galaxies in the observable universe, and each of these galaxies has the potential for intelligent life. This means that the actual number of potential alien civilizations in the universe could be significantly higher than what the Drake equation suggests. However, due to the vastness of the universe, the chances of us detecting these civilizations become even lower. The Drake equation has been and continues to be a valuable tool in helping us understand the likelihood of finding intelligent life in our galaxy. By breaking down the numerous factors that contribute to the emergence and sustainability of life, this equation has helped guide researchers in their search for extraterrestrial intelligence. However, it is important to remember that the Drake equation is not a perfect solution and has its limitations. The vastness of the universe and our limited understanding of the complexities of life make it difficult to come up with a definitive answer. As our technology and understanding of the universe continue to advance, it is likely that the Drake equation will also evolve, allowing us to refine our estimates and get closer to answering the age-old question of whether we are truly alone in the universe. What are the different types of potential alien life forms that could exist? To answer this question, we first need to understand what constitutes life and how we can categorize it. The most basic definition of life is the ability to metabolize and reproduce. Based on this definition, we can divide potential alien life forms into 3 main categories: microbial life, intelligent life, and advanced life. When we envision potential alien life forms, our mind often jumps to images of intelligent beings with advanced technology. However, it is highly likely that the first forms of life we may encounter beyond Earth will be at the microbial level. Microbial life includes bacteria, archaea, and single-celled organisms. These tiny life forms have the ability to thrive in extreme conditions, such as extreme temperatures, high radiation levels, and lack of water or oxygen, making them ideal for surviving in space. One example of potential microbial alien life forms is found in the subsurface oceans of icy moons in our own solar system, such as Europa and Enceladus. These icy moons have been found to have liquid water under their frozen surfaces, and scientists believe that the conditions there could be similar to those on Earth billions of years ago, making them potential hosts for microbial life. Another potential habitat is the atmosphere of gas giants like Jupiter and Saturn, where it is believed that aerial microbial life could exist. Intelligent life refers to beings that have the ability to think, reason, and communicate. This is often what we think of when we hear the term alien life forms. However, while we may have a preconceived notion of what intelligent life may look like, it is important to remember that as we encounter life beyond our planet, it may be vastly different from what we have imagined. One of the key factors in determining if a species is intelligent is the presence of a central nervous system and a brain. On Earth, we only have one example of intelligent life: humans. But beyond our planet, scientists speculate that other forms of intelligent life could exist. One theory is that we may encounter gray aliens, which are often depicted as small humanoid beings with large heads and almond-shaped eyes. However, this depiction is often based on pop culture and science fiction. Another potential type of intelligent alien life forms could be silicon-based life. On Earth, all living organisms are carbon-based, but there is speculation that life forms based on silicon could exist. Silicon is one of the most abundant elements in the universe and has chemical properties that are similar to carbon, making it a potential building block for life. Some scientists also propose the idea of energy-based life, which would not require physical forms, but rather exist as pure energy beings. While microbial and intelligent life forms are often the focus of our research for extraterrestrial life, it is also essential to consider the possibility of advanced life forms. Advanced life refers to beings that have evolved beyond microbial and intelligent life and have achieved a higher level of development and complexity. These beings could have evolved on planets that have advanced ecosystems and could have a greater understanding and mastery of the universe. One of the concepts often discussed in science fiction is the idea of post-biological life, which suggests that advanced life forms may no longer require physical bodies and could exist as a form of technology or energy. This could explain the lack of contact or communication with potential advanced alien life forms, as they may have evolved beyond the need for physical spaceships or communication devices. Another potential type of advanced life could be sentient machines. With the rapid advancement of artificial intelligence, it is not far-fetched to consider the possibility of machines achieving self-awareness and evolving into a form of advanced life. They could possess advanced cognitive abilities and may be capable of creating and exploring the universe in ways that are beyond our understanding. In conclusion, the three main categories of potential alien life forms, microbial, intelligent, and advanced, provide us with a glimpse of the possibilities of life beyond Earth. As we continue to explore and discover the vastness of our universe, it is essential to keep an open mind and be prepared for the unexpected. The search for potential alien life forms is an ongoing journey, and it is our curiosity and thirst for knowledge that will drive us forward in our quest to understand our place in the universe. With advancements in technology and increased interest in space exploration, the possibility of encountering intelligent life forms from other planets seems more within our reach. However, this raises an intriguing question. If the universe is seemingly teeming with potential life, why haven't we made contact with any of them yet? This conundrum is known as the Fermi Paradox, a theory named after Italian-American physicist Enrico Fermi, who first posed the question in the 1950s. The paradox raises a fundamental question. If there are billions of Earth-like planets out there, capable of sustaining life, Why have we not found any signs of intelligent life forms or made any contact with them? To understand the relationship between the Fermi Paradox and the idea of aliens visiting Earth, we must first delve into the details of the paradox. What is the Fermi Paradox? The Fermi Paradox refers to the apparent contradiction between the high probability of the existence of extraterrestrial civilizations and the lack of any evidence of their existence. It can be summarized by the simple question, where is everybody? In 1950, while having lunch with his colleagues, Enrico Fermi, one of the great physicists of the 20th century, posed this question after discussing the high probability of the existence of extraterrestrial life. The idea was simple. With billions of stars in the Milky Way and the sheer number of potentially habitable planets, it is highly likely that there are other intelligent civilizations in the universe. So, why haven't we seen or heard from any of them? To understand the Fermi Paradox, we must look at the underlying factors that make it a compelling and thought-provoking concept. Over the years, astronomers have discovered numerous planets outside our solar system, called exoplanets, which have similar characteristics to our own Earth. According to recent estimates, there could be as many as 300 million exoplanets in our galaxy alone, with the potential for Earth-like conditions. The sheer number of Earth-like planets raises the possibility that conditions for life may exist on them as well. With the abundance of potential habitats in our universe, the chances of life existing on other planets seems highly likely. The universe is nearly 14 billion years old, and our own solar system is around 4.6 billion years old. This means that there has been ample time for life to evolve and civilizations to emerge on other planets. Considering that humankind has only been able to observe a fraction of the universe, it is possible that there may already be civilizations out there that have evolved and potentially even gone extinct. In the relatively short span of human existence on Earth, we have made tremendous advancements in technology and space exploration. Our ability to send probes and rovers to other planets, as well as developing technologies that can detect exoplanets, has come a long way in recent decades. With such advancements, it is reasonable to assume that other highly advanced civilizations should also exist and potentially even surpass our own technological capabilities. Perhaps one of the most intriguing explanations for the Fermi Paradox is the idea of the Great Filter. This theory suggests that there is a barrier that prevents life from evolving into more advanced forms, and this could explain the rarity of advanced civilizations in the universe. The Great Filter could be an event or a set of circumstances that either destroys advanced civilizations or prevents them from progressing beyond a certain point. This could be a catastrophic event, such as a natural disaster, or self-destruction caused by technological advances. But if there are potentially habitable planets and the universe is billions of years old, why haven't we seen or heard from any of the civilizations? Many theories have been put forward to explain the absence of contact with intelligent extraterrestrial life. Some believe that advanced civilizations have already visited Earth in the past, and there is evidence to support this theory. The ancient Indian epic, the Mahabharata, describes advanced flying machines called vimanas that could travel through air and space. There are also many ancient cave paintings and artifacts that depict what appear to be beings from other worlds. These findings have led some to believe that there may have been past contact with extraterrestrial beings, and their influence and technology may have been the basis for the development of human civilization. On the other hand, some theories suggest that aliens may be actively avoiding contact with Earth or are observing us without revealing their presence. This could be because they perceive us as a primitive and potentially harmful species, not yet ready for contact with more advanced civilizations. Another popular theory is that alien civilizations are simply too far away for us to detect or communicate with. While our technological advancements have allowed us to observe and search for exoplanets, the vastness of space makes it challenging to detect any signs of life on them. It is possible that there are other advanced civilizations out there, but the distances are too great for us to make any contact with them. Can the laws of physics as we know them allow for the existence of advanced alien civilizations? The laws of physics are a set of fundamental principles that govern the behavior of matter and energy in the universe. These laws, which include gravity, electromagnetism, and the strong and weak nuclear forces, have been carefully studied and tested over centuries through observations and experiments. They are the backbone of our understanding of the physical world and have allowed us to make incredible advancements in technology and astronomy. However, our understanding of these laws is not perfect. Einstein's theory of general relativity, which describes the force of gravity, has been successfully tested on a large scale, but is yet to be reconciled with quantum mechanics, which governs the behavior of particles on a small scale. In other words, while we have a good grasp of how the universe works on a macroscopic level, the same cannot be said for its microscopic workings. Additionally, our understanding of the laws of physics is limited by our technology and observational capabilities. The universe is vast, and we have only explored a small fraction of it. There could be phenomena and laws of physics beyond our current understanding that remain to be discovered. One of the most fundamental questions in the search for extraterrestrial life is whether the universe can support it all. To answer this, we must look at the conditions necessary for life to exist. First and foremost, a planet must exist in the habitable zone of a star, where the temperature is just right to support liquid water. The planet must also have a stable atmosphere, a source of energy, and crucially, the right chemical elements. Luckily, the universe is teeming with all of these ingredients. In fact, exoplanet research has discovered thousands of potentially habitable worlds, with a handful of them being Earth-like in size and composition. This indicates that the conditions for life are not as rare as once thought. However, the question remains, can the laws of physics allow for the evolution of complex life forms on these habitable worlds? Our universe seems to be just right for the existence of life. The laws of physics have been finely tuned to allow the formation of galaxies, stars, and planets, all necessary for the formation of life. This has led some to believe that the universe must have been designed by a higher power. But it can also be explained by the anthropic principle. The anthropic principle states that the universe must be able to support life because we are here to observe it. In other words, if the laws of physics were different, we would not be able to exist and question them. This can be likened to a Goldilocks scenario, where the universe is not too hot, not too cold, but just right for the development of life. However, the anthropic principle also raises significant questions. Why is the universe fine-tuned for life? And how did these laws of physics come to be? Does this mean that there could be other universes with different sets of laws? And if so, could they support the evolution of life? The possibility of multiple universes, or a multiverse, has been proposed by many physicists and cosmologists to explain the fine-tuning of our universe for life. This theory suggests that our universe is just one of an infinite number of parallel universes, each with its own set of physical laws. The multiverse theory remains highly debated, as there is currently no way to prove or disprove its existence. However, if it is true, then the laws of physics in these other universes could be drastically different from our own. This opens up the possibility that an advanced alien civilization could exist in a universe with completely different physical laws, making it impossible for us to comprehend their existence. As mentioned earlier, our understanding of the laws of physics is limited by our technology and observational capabilities. This means that there could be phenomena and physical laws beyond our current knowledge that allow for the existence of advanced alien civilization. For example, we have only recently begun to explore the possibilities of dark matter and dark energy, which make up a significant portion of the universe, but remain largely mysterious. Could these elusive substances hold the key to understanding the potential for advanced life forms in the universe? Or perhaps there are other fundamental forces at play that we have yet to discover, which could have a crucial role in determining the existence of extraterrestrial life. The search for advanced alien civilizations has primarily focused on finding technologically advanced life forms that could communicate with us. This has led to the development of the SETI program, which scans the universe for potential signals from other intelligent beings. However, this approach assumes that advanced alien civilizations would have similar technological capabilities as us. It also relies on the concept of electromagnetic waves for communication, which may not be the only means of communication for an advanced species. In conclusion, the laws of physics as we know them do allow for the existence of advanced alien civilizations, but it may be in forms that we cannot comprehend or even imagine. Our understanding of the universe is limited, and there are many unknowns that could play a crucial role in the evolution of intelligent life beyond our own. While we may never have all the answers, our constant pursuit of knowledge and exploration of the universe will undoubtedly continue to shape our understanding of the laws of physics, life, and the potential for advanced alien civilizations. What role does the search for exoplanets play in the search for extraterrestrial life? Exoplanets refer to planets that exist outside of our solar system, and their discovery has opened new possibilities in the search for alien life forms. But what role does the search for exoplanets play in the larger quest for extraterrestrial life? To understand this, one must first understand the concept of habitable planets. A habitable planet, also known as a Goldilocks planet, is a planet that possesses the right conditions for life to exist. This includes the presence of liquid water, a stable atmosphere, and a suitable distance from its host star. Since the discovery of the first confirmed exoplanet in 1992, scientists have identified thousands of exoplanets, some of which fall within the habitable zone of their respective stars. The search for exoplanets has expanded our understanding of the universe and has led to a better understanding of the conditions necessary for the existence of life. It has also paved the way for the identification of potentially habitable exoplanets, bringing us one step closer to answering the age-old question: are we alone in the universe? One of the main ways in which the search for exoplanets aids the search for extraterrestrial life is through the identification of potential habitable planets. With the help of advanced telescopes and other scientific tools, scientists are now able to detect the presence of planets orbiting distant stars. By studying the characteristics of these planets, such as their size, composition, and distance from their star, researchers can determine if they fall within the habitable zone. One of the most famous examples of a potentially habitable exoplanet is Proxima Centauri b, a rocky planet that orbits the closest star to our Sun. It is located within the habitable zone of its star and has the potential for liquid water to exist on its surface. This discovery has sparked excitement among scientists, as it offers hope for the existence of extraterrestrial life in our nearest star system. In addition to identifying potentially habitable planets, the search for exoplanets also allows us to study the conditions on these planets. This involves analyzing their atmospheres for the presence of key molecules such as water vapor, oxygen, and methane. These molecules are known as biosignatures and can indicate the presence of life on a planet. For example, the presence of oxygen in an exoplanet's atmosphere could suggest the existence of photosynthetic plants or organisms, as oxygen is a byproduct of photosynthesis. Similarly, methane can be produced by certain types of bacteria, making it a potential biosignature. By detecting these molecules on exoplanets, scientists can gather evidence for the presence of life. Moreover, the search for exoplanets has also aided in the development of new technology and techniques that can be used in the search for extraterrestrial life. One such technology is the transit method, which involves observing the dimming of a star's light as a planet passes in front of it. This method has been crucial in identifying exoplanets and has been used to gather data on their composition and atmospheric conditions. Another technique used in the search for exoplanets is the radial velocity method, which involves measuring the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. This method has been instrumental in the discovery of thousands of exoplanets and has also helped in the search for Earth-like planets that could potentially harbor life. Furthermore, the search for exoplanets has also led to the discovery of diverse planetary systems and environments that were previously thought to be impossible. For example, the discovery of hot Jupiters, gas giants that orbit extremely close to their parent stars, has challenged the long-held belief that Earth-like planets can only exist in the habitable zone. This has expanded our understanding of the conditions under which life can exist, opening up new possibilities in the search for extraterrestrial life. One of the most significant findings in the search for exoplanets is the evidence for the existence of water on other planets. Water is a crucial element for the survival of life as we know it, and its presence on other planets greatly increases the chances of finding extraterrestrial life forms. The recent discovery of liquid water on Mars and the confirmation of a subsurface ocean on one of Jupiter's moons, Europa, are promising leads in the search for extraterrestrial life. In addition to water, the discovery of other elements such as carbon, nitrogen, and sulfur on exoplanets has also piqued the interest of scientists. These elements are important for the formation and sustenance of life, and their presence on exoplanets has raised the possibility of finding alien life forms that may have evolved using different biochemical processes. The search for exoplanets is also crucial in understanding the potential habitability of our own planet. By studying the characteristics and environments of exoplanets, scientists can gain a better understanding of the conditions that led to the formation and evolution of Earth. This allows us to appreciate the unique qualities of our own planet and the factors that make it an ideal environment for life to thrive. In conclusion, the search for exoplanets is playing a vital role in the larger quest for extraterrestrial life. It has expanded our understanding of the universe and has opened up new possibilities for the existence of alien life forms. The identification of potentially habitable planets, the discovery of diverse planetary systems, and the development of new technologies and techniques are all contributing to the search for extraterrestrial life. As we continue to learn more about the universe, we come one step closer to answering the age-old question, are we alone? Can the study of UFO sightings and encounters provide any scientific evidence for the existence of aliens? To answer this question, we need to first understand the concept of UFOs and how they are studied. UFO, or unidentified flying object, is any object or light in the sky that cannot be explained by conventional means. It does not necessarily mean that the object is of extraterrestrial origin. It simply means that we do not know what it is. The study of UFO sightings and encounters falls under the field of ufology, which involves the analysis of reported sightings, physical evidence, and eyewitness testimonies. Ufologists gather and analyze data, conduct investigations, and try to find logical explanations for these unknown sightings. One of the main arguments for the existence of aliens is based on the sheer number of reported sightings. According to the National UFO Reporting Center, There have been over 120,000 reported sightings in the United States alone since 1947. This number is significantly higher if we take into account global reports. While skeptics may argue that these sightings could be explained by natural phenomena, military aircraft, or advanced technology, there is still a small percentage of cases that remain unexplained. These unidentified sightings are known as true UFOs and are the focus of ufologists' research. One of the challenges in studying UFOs is the lack of physical evidence. Unlike other fields of science, where experiments can be conducted in a controlled environment, UFO sightings are unpredictable and cannot be recreated. This makes it difficult to gather empirical evidence and analyze it scientifically. Another obstacle is the lack of funding and official recognition for the study of UFOs. Most scientific institutions do not take ufology seriously, and it is not considered a reputable area of study. Without proper funding and support, it becomes challenging to conduct thorough research and investigations. Despite these challenges, there have been several cases where UFO sightings have provided some intriguing scientific evidence for the existence of aliens. One such case is the 1964 Lonnie Zamora incident in New Mexico. Zamora, a police officer, reported seeing a metallic egg-shaped object with two humanoid figures near it. He even claimed to have seen alien-looking footprints on the ground. The case gained national attention, and researchers from the University of Colorado conducted a thorough investigation. They found physical evidence such as landing marks, burnt brush, and unusual metal alloys, leading them to believe that something out of the ordinary had indeed occurred. However, the official conclusion was inconclusive, and the incident remained a mystery. In recent years, there has been an increase in scientific interest in studying UFOs. The Pentagon has also released several videos of UFO sightings captured by U.S. Navy pilots, raising questions about the government's involvement in investigating these sightings. In 2019, physicist and astrophysicist Avi Loeb published a paper about an interstellar object known as Oumuamua. This object was first detected in 2017, and its unusual shape and movement have led many to believe that it could be an alien spacecraft. Loeb's paper suggested that Oumuamua could be an alien probe sent to explore our solar system. While Loeb's theory is highly debated, his paper and the scientific community's response have sparked an important discussion about the possibility of extraterrestrial life and the need for further research in this field. Apart from reports and physical evidence, some scientists argue that the study of UFOs can also provide evidence through the analysis of human reactions. In his book, The Myth of the UFO, Dr. Thomas Bullard, a folklorist, suggests that the study of UFOs and its impact on our culture and society could provide valuable insights into human psychology and beliefs. According to Dr. Bullard, UFO sightings can be seen as modern-day folklore, a reflection of our fears, hopes, and dreams. It raises questions about the societal and cultural factors that drive our beliefs in extraterrestrial life and the impact of these beliefs on our understanding of the universe. However, there are many who vehemently deny the possibility of aliens and believe that the study of UFOs is a waste of time and resources. They argue that the sightings and encounters can all be explained by natural or man-made phenomena, such as weather balloons, drones, or military experiments. Skeptics also point out that in many reported sightings, the witnesses' reliability and credibility are questionable. Some sightings have been proven to be hoaxes, and there have also been cases of mass hysteria, where people have reported seeing UFOs when there was nothing in the sky. With the advancements in technology, it has become easier to create elaborate hoaxes, making it more challenging to distinguish between real and fabricated reports. This makes it even more critical for ufologists to gather credible evidence and conduct thorough investigations to differentiate between genuine sightings and hoaxes. In conclusion, the study of UFO sightings and encounters can provide some evidence for the existence of aliens, but it cannot be considered conclusive. Where there have been intriguing cases and physical evidence, the lack of empirical evidence and the challenges in studying this subject make it difficult to arrive at a definite answer. But let us just assume there are aliens. What would they be like from a scientific point of view? Biology plays a crucial role in understanding the potential form and function of an alien. The basic building blocks of life on Earth are carbon, hydrogen, oxygen, and nitrogen, which make up the majority of organic compounds. However, this may not be the case for an alien species. The fundamental components of life could differ significantly, with elements such as silicon, sulfur, and phosphorus being potential substitutes for carbon. This would result in a completely different biochemistry for the alien species, making them almost unrecognizable to us. The environment in which an alien species evolves also plays a significant role in its biology. On Earth, living organisms have adapted to various environmental conditions, such as extreme temperatures, pressure, and radiation. Similarly, an alien species would have evolved to thrive in their unique environment. For example, a species that evolved on a planet with a dense, toxic atmosphere would have developed respiratory systems that are vastly different from ours. The concept of evolution also applies to aliens, as it is a natural process that governs the development of life on any planet. However, the mechanisms of evolution may differ from what we know. For instance, an alien species could possess a much faster rate of mutation, allowing them to adapt to changing conditions at a quicker pace. This could lead to a highly diverse and rapidly evolving species, making it challenging for humans to gather a complete understanding of their biology. Another crucial aspect of an alien's biology is its reproductive system. On Earth, reproduction is primarily divided into two categories: sexual and asexual. However, there could be other forms of reproduction that exist in the universe. For instance, a species could reproduce through cloning, or a combination of both sexual and asexual methods. This could also have a significant impact on their social behavior and interactions. For centuries, human beings have looked up at the night sky and wondered about the possibility of life beyond Earth. This fascination with extraterrestrial life has been a subject of countless books, movies, and television shows. However, the question of whether aliens truly exist and if they have ever visited our planet has remained a mystery. But one thing is for sure: Science and technology are advancing at a rapid pace, and it is only a matter of time before we have concrete evidence that aliens not only exist, but have also visited Earth. One of the most significant breakthroughs in our quest for extraterrestrial life came in 2015, when NASA's Kepler Space Telescope discovered an Earth-sized planet in the habitable zone of a star about 1,400 light-years away. This planet, known as Kepler 452b, has been dubbed Earth's cousin due to its similarities in size and distance from its star. This discovery has given scientists hope that there could be many more habitable exoplanets in our galaxy alone. But the question remains, even if there are habitable exoplanets, does that mean there is life on them? To answer this, we must look at the conditions necessary for life to exist. Moreover, scientists have also found evidence of organic molecules, the building blocks of life, on comets and meteorites. This suggests that the ingredients for life are present in various parts of the universe, and it is only a matter of time before they come together to form living organisms. But what about the possibility of intelligent life? Could there be beings like us, capable of advanced technology and space travel, out there in the vastness of space? This is where the topic of alien visitation comes into play. There have been countless reports and sightings of UFOs and extraterrestrial beings over the years, but most of them have been dismissed as hoaxes or misidentified natural phenomena. However, there are a few cases that have left even the most skeptical scientists scratching their heads. One of the most famous cases is the Roswell incident of 1947, where a mysterious object crashed in the New Mexico desert, and the government quickly covered it up, sparking rumors of a crashed alien spacecraft. Although the official explanation was that it was a weather balloon, many believe that it was indeed an extraterrestrial craft, and that the government has been hiding the truth from the public. Another intriguing case is the Phoenix Lights incident of 1997, where thousands of people in Arizona witnessed a formation of lights moving across the sky. The official explanation was that it was flares from a military exercise, but many witnesses claim that the lights were in a V-shape, making it impossible for them to be flares. This event remains unexplained and has led to speculation that it was a massive alien craft. But perhaps the most compelling evidence for the existence of aliens came in 2004, when the U.S. Navy released declassified footage of a UFO encounter by their pilots. The footage showed an unidentified object moving at incredible speeds and performing maneuvers that are impossible for any known aircraft. This incident, along with many others that have been declassified, has raised questions about the government's knowledge of extraterrestrial visitation. Furthermore, there have been claims by high-ranking military and government officials, such as Paul Hellyer, the former Canadian Minister of Defense, that aliens have not only visited Earth, but have also been in contact with us for years. These claims, along with the declassified footage and official government investigations, have added credibility to the possibility of an alien visitation. But perhaps the most exciting development in recent years has been the emergence of new technologies that could help us in our search for extraterrestrial life. The Breakthrough Listen project, launched in 2015, is a 10-year, $100 million initiative to scan the skies for signals from intelligent civilizations. With the help of advanced radio telescopes, This project has the potential to detect radio signals from alien civilizations up to 40 light-years away. Quantum physics could also prove the existence of aliens and their visitation to Earth. Quantum physics is a branch of physics that studies the behavior of matter and energy at a microscopic level. It is known to be weird and counterintuitive, with phenomena such as entanglement and superposition, which still remain largely unexplainable. These characteristics of quantum physics make it a perfect tool to investigate the possibility of extraterrestrial life. The first concept of quantum physics relevant to proving the existence of aliens is the idea of parallel universes. According to this theory, there are infinite universes that exist alongside our own, each with their own set of physical laws and different versions of reality. This means that there could be a parallel universe where aliens exist and have successfully developed advanced technology to travel between universes. Therefore, it is possible that they have visited Earth through one of these parallel universes. There's also quantum entanglement, where two particles can be connected and affect each other's state, even if they are separated by great distances. This means that an extraterrestrial civilization could potentially use quantum entanglement to communicate and travel vast distances, possibly even reaching Earth. Furthermore, quantum physics also suggests the existence of black holes, which are regions in space where the gravitational pull is so strong that even light cannot escape. Black holes are considered to be the most extreme and mysterious objects in the universe, and many scientists believe that they could be a gateway to other dimensions or even other universes. It is possible that advanced extraterrestrial civilizations have developed the technology to harness the energy of black holes and use them as a means of transportation, making intergalactic travel possible. Quantum physics has also provided evidence for the existence of multiple dimensions. In this theory, our three-dimensional world is just one of many, with higher dimensions existing beyond our comprehension. It is possible that aliens come from one of these higher dimensions, and their advanced technology allows them to enter and explore our world. This could explain the strange and seemingly impossible abilities of some reported alien sightings, such as shape-shifting and disappearing in plain sight. Some scientists also believe that the technological advancements of aliens may surpass our own due to their understanding of advanced quantum computing. Quantum computing utilizes the properties of quantum physics to perform calculations at a much faster rate than traditional computers. If aliens have mastered this technology, it could explain how they are able to travel vast distances in a short amount of time, making their presence on Earth possible. The concept of parallel universes, quantum entanglement, black holes, multiple dimensions, and advanced quantum computing all support the idea of extraterrestrial life and their technology. With all these advancements and discoveries, it is only a matter of time before we have solid proof of the existence of extraterrestrial life. And when that day comes, it will change our understanding of the universe and our place in it forever. We will no longer be alone in this vast expanse of space, and the possibilities for future discoveries and interactions with alien civilizations are endless. Science has brought us closer than ever to the truth about the existence of aliens and their possible visitation to Earth. With the discovery of habitable exoplanets, evidence of organic molecules in space, and advancements in technology, the possibility of life beyond Earth is no longer a question of if, but when. And when that day comes, it will be a momentous occasion that will forever change humanity's perception of the universe. So, let us keep looking up at the stars with wonder and excitement, for the truth about extraterrestrial life may be just around the corner.